we're going to take a look at how to solve some really basic sorts of differential equations. And in the types we're going to be solving in this section, we literally just have the derivative on one side and then the independent variable on the other side. And so we're just going to integrate to be able to solve these. All right, so a really basic example we have, y prime of x equals sine 3x plus 4. So realistically, what we're going to do is we're going to integrate y prime of x with respect to x, all right? And that's going to be equal to the integral of sine 3x, what does that say, 3 sine x, but sine 3x plus 4 dx. All right. And then if we integrate the y prime of x, that just becomes y at x, all right? Because it's a derivative of a function in terms of x, right? And we just find the antiderivative. That's our fundamental theorem of calculus part 2. Antiderivative of sine is going to be negative cosine, but we're going to use the reverse of the chain rule on this, all right? So it's actually going to be not multiplied by 3, but divided by 3 in this case. Antiderivative of 4 with respect to x is 4x, and then we have a constant of integration. All right, so that is literally how you solve a really basic differential equation, not meant to be too difficult. Okay, another example, y prime of t, 14 t to the 6th, 36 t to the 5th, 4, 7 over t to the 6th. All right, again, we're going to integrate both sides, but this time with respect to t. Right, so this is y prime of t dt, and then the integral of 14 t to the 6th, 36 t to the 5th, 4. And then I'm just going to set this up by writing it as 7t to the minus 2 instead of 7 over t squared dt. Right? And so we know that the antiderivative of y prime of t is just going to be y of t. Right? And this is going to be 14 sevenths t to the 7th plus 36 over 6 t to the 6th plus 4t, and then plus 7 over negative 1 t to the minus 1 plus a constant of integration c. Right? And then finally, we could simplify this and get 2t to the 7th, 6t to the 6th, 4t minus 7 over t plus c. All right. Again, really basic example. This is almost like a calculus 1 problem where we just have to go through and find the antiderivative. All right. Now, another example here, we have y prime of x equals 2 ln of x minus 4. All right. So looks pretty innocent. So we're going to integrate our y prime of x with respect to x, and then we're going to integrate our 2x ln of x minus 4 dx. Now, this is more of a Calc 2 problem because of this animal right here, the 2x ln of x. All right, so let's go ahead and just break this up into 2 separate intervals. Okay, so this is going to be 2x ln x dx minus integral of 4 dx. All right, and we know this one, that's just going to be 4x, and then we can put our plus c in there right away. And technically, it should be negative 4. All right. But this guy right here is a parts. All right, so that's why it's more of a Calc 2 problem, because we have to integrate this animal by parts. Now, usually what we would do is we would let u equal 2x and dv be ln x dx. But if we do that, there's no basic antiderivative for ln x. We would actually have to do that by parts. All right, so, and you probably remember this one from our assignments and our exam. All right. So u is going to be equal to our ln x, and then dv is going to be 2x dx, right? Remember, by parts, you find the derivative, all right? So derivative of ln x is 1 over x dx, and then you find your antiderivative of 2x, which is going to be 2x squared over 2, or just x squared, all right? And now we just remember our formula for integration by parts. So remember, it's going to be uv minus integral v du. All right, and so we know uv and then v du. All right, so this is going to be ln x squared, or sorry, ln of x times x squared, excuse me. All right, so ln of x times x squared minus the integral of v du, which is going to be x squared times 1 over x dx, all right? And so if we simplify this, all right, and I'm just going to write the x squared out front. So we have x squared ln x minus, we have an x and it's squared times a 1 over x is just going to be x dx. And so when we finish out just the parts, we're going to get x squared ln x minus x squared over 2. But we can't forget that we had the minus 4x plus c. And also remember that this is going to be y at x. And so our entire solution for this is going to be y at x is going to be equal to the x squared ln x minus x squared over 2. And then we can't forget that we had minus 4x plus c. All right, so sometimes we have to remember that our basic sort of integration by parts and some of our techniques that we learned in the previous sections are going to come back. All right, and of course we know that integration is one of the more difficult operations in mathematics. All right, so in the next video, we're going to take a look at a few more examples of just solving some really elementary differential equations.